Next is bearing failure at the base of column. So to ensure the safety against bearing failure at the base of column, what we need to do? So the load from column to footing is transferred by two means: by direct bearing of column or concrete over the footing, and by force in dowels or column reinforcement which across the interface between column and footing. So the total load, the applied load, is carried by the concrete as well as this dowel reinforcement or the reinforcement of the column which transfer or which cross this interface. So here if we see the column at this stage is resisting the load, some portion by concrete and some portion by steel. The total load of the column is resisted by this concrete as well as steel. But as we go downward near to the interface between column and the footing, if the reinforcement of column is terminated at the face of the footing, so the load carried by this steel will continue to decrease. So the load carried by this steel is continue to decrease and it will become zero at the face of the footing. And as a result, the total load will be resisted by the concrete. So the fraction or the portion of the load which is resisted by the concrete continue to increase, and at the face of the support most of the load or the total load is carried by this concrete. If we don't have any dowel reinforcement, then the total load at this point or at the interface of the column and footing will be resisted by the concrete. So in that case our concrete should be strong enough to bear the applied load, or otherwise we need to provide this dowel reinforcement so that some part of this load should be resisted by the dowel reinforcement. So it can be resisted by the concrete and the dowels. So if dowels are not provided, then the whole load at interface will be resisted by the concrete only. To avoid failure at this interface, either the strength of concrete should be enough to resist the load or dowel reinforcement should be provided to resist the load. So to make this structure safe or to safeguard against the bearing failure at this position, either we need to increase the strength of concrete so that the concrete alone should be able to resist the load of column, or otherwise we need to provide this dowel reinforcement so that the load which was carried by the reinforcement in the column should be transferred to the dowel reinforcement, and concrete should resist the same load that it was resisting in the column at the interface of the footing. Okay, the bearing strength provided by the column concrete is given by this one. The strength provided by the concrete, it is equal to phi 0.85 Fc prime Ag, and here phi is 0.65. In case of compression, we consider this factor 0.65. And bearing strength to be provided by the dowels is equal to PD, and it is the difference or the net of the applied load. So PU minus the load resisted by the concrete. So PU is the total load of column and phi PNC is the load resisted by the concrete. So the remaining portion will be resisted by the dowels. So the area of steel required for the dowel is equal to load resisted by dowel divided by phi Fi. So this is simply sigma is equal to P over A. So we just need to rearrange this equation. A is equal to P over sigma. So at the design stage we consider the limit state and we consider that our reinforcement should reach at its yield strength. So the area required will be equal to Pu applied load divided by the Fy, and we multiply it with the reduction factor phi, which is 0.65. So in this way we can calculate the area of steel required to resist the additional load, or area of dowel reinforcement to resist this PD, the load that must be resisted by the dowels. So the ACI specifies that the minimum area of steel required for dowel should be equal to 0.005 times gross area, and AG is the gross area of the supported member or area of columns. So we need to provide 0.5% reinforcement for dowels or the higher value calculated from here. So next is bearing failure. Next is bearing failure of footing at the base. So if our column is strong enough and it doesn't fail at the interface, there is a possibility that the concrete of the footing may fail in the bearing. So we need to check the concrete of footing against bearing. So the bearing strength provided by the foundation concrete can be calculated by using this formula, which is 0.85 Fc prime time area of the column multiplied by A2 over A1, and it should be less than 2 times of 0.85 Fc prime A1. Here A2 is the area of footing effective in resisting the bearing stress at a certain depth inside the footing, calculated by taking distribution of 1 vertical and 2 horizontal. So we consider the distribution of stress inside the footing by 1 vertical and 2 horizontal. So if the case is like this, the footing is sufficiently large and this tributary area lies within this footing, so in that case the area will be considered at this location, at the bottom of this footing. So if this is H or D, so we will go in this direction equal to 2H, and in this direction 2H, and similarly 2H on all 4 sides. So we can calculate this area at this level. So the total will be 4H plus the dimension of the column. For example, it is C1. Similarly, it will be multiplied with 4H plus C2. So it will give us A2. But if this column is close to one edge, so in that case, if we consider this distribution 2:1, so we will reach up to the edge of this footing at a certain depth. So at this depth, we will reach at the edge of this footing, and the area at this level will be considered. So here it is more clear. We have a column and its distribution is considered like this. So at this level we have reached at the one face of the footing, so the area at this level will be considered. And if we see in the plane, so it will be like this. So whatsoever is this much distance, this will be considered on this side, as well as on this side. So it will be considered on 4 sides. So what we need to do, if it is L, so (2L plus C2 times 2L plus C1), it will be equal to A2. So to simplify this, or to avoid the complication, what we need to do, we can see our column in plane. For example, we have a column in plane like this. So if our column lie over here, so we need to see all these edge distances. For example, this is L1, this is L2, this is L3, and this is L4. And we need to compare these L1 to L4, and these should be less than H. For example, so it should be less than 2 times H. For example, L1 is the least of these 4, so L1 is less than 2H. It is less than 2H, so we will consider L1 as the governing factor. So in that case, our A2 will be equal to, so we will consider L1 on this side, so our area will be like this much area. So on all 4 sides we will have the projection from the face of the column equal to L1. So this dimension will be equal to L1, C2 or C1 and L1 from here up to here and then here. Similarly on this side we will have L1, L1 and C2. So we will have 2L1 plus C1 times 2L1 plus C2. So it will give us A2. But if the case is like this, that we have column over here, this is L1, L2 L3 and L4. So L1 to L4 are less than equal to 2H, but here these are L1 to L4 are greater than 2H. So in that case we will consider this 2H, and A2 will be equal to, so in that case we need to consider this 2H. So 2H will be over here. So from here up to here, this will be 2H, this will be C1, this will be 2H. Similarly on this side, this is 2H, this is C2, and this is 2H. So it will become 4H plus C1 times 4H plus C2. So from here we can calculate A2. So we just need to consider the least projection and then compare it with the 2H and then select the least value out of these two. Least projection and 2H, the smaller value out of these two, and then put it over here. Okay, once we have A1 and A2, we can easily calculate this, the load resisted by the concrete in case of footing, or the bearing strength provided by the footing concrete. So the bearing strength to be provided by the dowel in footing concrete is equal to PD. It is again the applied load on the column minus the strength provided by the footing concrete. And the area of steel required for the dowel is load resisted by the dowel divided by 5 Fy. So from here we will get the area of the dowel reinforcement, and based on the area we can select the number of bars, and the minimum area should be more than 0.005. If this area is less than 0.005 AG, so we need to consider this value. So in this way we will provide the dowel reinforcement. So the next is general procedure for footing design. So this will be covered in the next video.